There it is. Okay. So what I have on the screen, you recognize, I hope, is the preference table that we had the first week, and I have massaged it just slightly. I think there were two different groups that liked, or two different individuals who preferred stir fry to chicken patty to pizza. And so I just combined them into a single column for my own reasons. I know you know that I support the chicken patty above all else, but the reason is that I wanted to take a look at this and see if you could think of any way. So currently, the way that this stands, if we use what is typical of voting in America, which is just a plurality, whoever has the most votes wins, then what we're going to have is that pizza wins. But take a look at the situation here, and I'll give you a couple of minutes to discuss with your neighbor or with your people in front of you, is there any way for the chicken patty people to affect the outcome of the election in some way, perhaps by changing the way that they vote, or maybe anyone. Is there anyone here who can change the outcome just by changing the way that they vote to make it maybe not what reflects their preference, but perhaps they can get a better outcome for themselves? So take a minute, see if you can come up with this, and then we'll discuss it together in a group, and then we're going to go over how to manipulate elections, which is fun, isn't it? It's so quiet. Maybe we'll do this as one big group instead of smaller groups. But is there anyone in this scenario who could change the outcome to an outcome that might be more preferable to them by maybe changing the way that they're voting? I guess I was focused on the chicken patty people, but they don't have any power, do they? The chicken patty people, that is those 4 people on the left, but there are some people who have power. Does anyone see who that is? Yeah, what do you think?
Maybe the stir fry.
Yeah, the stir fry people. They could change the outcome, couldn't they? What could they do? What could the stir fry people do to have an outcome that might be better for them? They're not going to get stir fry, but what could they do? What do you think? Yeah, just change their votes to chicken patty. And then, because their second choice is chicken patty, and they're like, you know what, we hate pizza. Maybe that's what these stir fry people are thinking, is that they much prefer that saucy goodness of a stir fry, but they despise pizza. And so if they just change their vote, change their preference to chicken patty over stir fry, then they can change the results of the election to something that might be better for them if they know ahead of time that this is the situation. This is the sort of thing that mathematicians, when they were studying voting theory originally back in the 1960s and 1970s, were worried about. They were concerned that if a particular maybe coalition of voters got together, they could change the outcome of the election by not voting sincerely, by saying, my preference is not stir fry, but rather it's chicken patty. It kind of makes sense, just looking at this, that would be the logical thing for the stir fry people to do, is to band together with the chicken patty people. And so that sort of thing is termed insincere voting. This is the idea of not voting what you really think, but voting in a way that's more strategic. And so in all of the various little paradoxes, or they're not really paradoxes, but these criteria that I've been calling them for fairness, they all point out a way that people could sort of manipulate the election in a way that might not be desirable in terms of trying to, our goal is to try to encapsulate the will of the voters, like have the thing that's going to be best for the most people have happen. So anyway, let's see, so you just have to switch over here to another example. Here we go. This is it. Okay, so here's another example of a situation. This illustrates this particular situation that the chicken patty stir-fry people getting together could, does this, that just is poor in terms of its, the color scheme that I used. I should have done something much more bold like you guys did in your presentations. So here is my preference table. Of course, this is first, second, and so forth. Third, fourth. Okay, so in order to describe this situation that we just discovered sort of with the chicken patty stir-fry people getting together, this illustrates that situation as well. So who's the plurality winner? So take a minute, I guess I could pick, I got to do attendance anyway. So I could pick someone randomly. I know you all know who the winner is, but give me a minute so that this will help me to do my job. I learned, I didn't know this about our school, but apparently our school is required by federal law to keep attendance records. So I used to just poo-poo this, and I'd be like, whatever. If I didn't do it, but I was surprised when I learned that. Okay, so give me a sec here. Take attendance. We'll do this. We have one person not here, and she is excused. Okay, I've done my job. So let's see, let's do a random student. Here we are. Chelsea, you know who the winner is, don't you? Who's the winner for this plurality winner? It's B, right? Is that what you said? Yeah. Yeah, that's right. Sorry, I can, there, it's 7. B is 7. Why do I put it equals 7 there? I don't know. B has 7 votes, so B is the winner. Now, tragically, the day before the election, one of the candidates passes away. Candidate A passes away. Now you would think candidate A, whatever, candidate A is not the winner, B is the winner. So just because candidate A, one of the losers, passes away, it shouldn't change the outcome of the election. But let's see what happens when candidate A dies. So candidate A tragically passes away. Now who is the winner for this election? So take a minute. Now remember, you can't vote for candidate A. They've been killed off, or they passed away because of natural causes. This was not like nowadays when I guess people are trying to kill everybody, but it's just, had a heart attack or something. So let's see. Oh, of course. Reagan, who's the new winner? Or I guess I shouldn't have given it away, but there is a new winner, isn't there? D. Yeah, D is the winner now. So D is the winner now. So before, when you had just the normal slate of candidates, you ended up with B being the winner, but then you got rid of one of the losers. So one of the losers dropped out of the race, and it changed the election. Ooh, fancy. I think I set it up to random slide changes. But so it changed the winner to D, which is somewhat surprising. This has a name. This is called the, at least for some mathematicians, I don't think this is in your book, but this is called the irrelevant alternatives criterion. So maybe we should list off all these criterion and then get some examples of them. So I had made a chart similar to this earlier, but here they are. So you have the methods that we've learned about, the plurality method. I realized that today you did 2 activities. One of them was for Black's method, but that was more of just a way of trying to reconcile 2 disparate winners. If you have a different winner for board account and the head-to-head method. Oh, we called, let's see, we didn't call it head-to-head. We called it Condorcet, didn't we? Condorcet method. And then there was the Condorcet criterion. The elimination method, that was the runoff method. I haven't updated these. So there they are. Oh. I don't know why it's beeping at me. So you have these four methods. You're familiar with them now. We have the plurality, the board account. You did a great job at explaining that. The elimination, that's the runoff method. You guys did a great job with that. And then the head-to-head method, or the Condorcet method. Those were the methods, how we decide on a winner. And then you could come up with some other methods, but these are the four main ones that we see being used nowadays. And then the criteria for fairness, the Condorcet criteria, majority, monotonicity, and irrelevant alternatives. I'll have examples of each one of these in just a minute. So I just wanted to have those up there since I was hinting at these. On Tuesday, one of the homeworks you have for Tuesday is to read over, I know these things are so short, is the little section on arrows and possibility theorem where it sort of describes what Kenneth Arrow tried to do back in the 1970s. His goal was to come up with a method that was perfect, that didn't have any of these things. He described it in terms of not being able to manipulate. It was undesirable for voters to be able to manipulate the outcome by voting insincerely. And each one of these, if one of these criteria is violated, it means that voters could manipulate the outcome by changing their votes. But anyway, getting back to this, let's take a look at some examples. Let's do another one just to illustrate the irrelevant alternatives criterion again, just so you understand what that means. So irrelevant alternatives just means that if someone who is a loser drops out of an election, the winner shouldn't change. It kind of makes sense. Let's say you have a slate of you have 10 different people in an election, and candidate A wins. Let's say that candidate F drops out. It shouldn't change the fact that candidate A is the winner. Just thinking through what would be fair. So here's another example, just so you know that this is not just a problem for plurality. Let's take a look at this, and I'll give you a minute to work through this. Let me make sure, is this it here? This one, yeah. Okay, so what I'd like to do, head-to-head, this is the Condorcet, that we've called the Condorcet method. And I've even helpfully jotted down the different pairings. So just to remind you, Condorcet method, we have to come up with pairings. So you pair up so it's like head-to-head matches, and we see who is the winner for each one of these. And then if there are ties, we'll have to deal with that a little later on. But whoever wins the most in head-to-head matches, that's the winner of the election using this method. So I'll give you a minute. Yeah, I forget which group did this. You did a great job explaining this. I'm not doing as good a job here. But take a minute, work with your friend if you need to. Maybe you could divide up the labor. Like if you have someone sitting next to you, one of you could do the A versus B and C and D, and the other one could do the right-hand column of the pairings. That'll save some time maybe. Or you could just crank it out yourself. There's not that many votes. Not too difficult to do. Is that visible enough? Yeah. I have to think of my color schemes more. I like your color schemes better when you did this. Oh, I feel like we need to have pastries or something. There's like so much quiet in here. We're not very excited, I guess, to be here on a Thursday morning. Honestly, I'm not that excited either. So I think I told you Thursday was traditionally the day that I didn't have to, get up early or whatever. Well, let's give it a go here. We can make this happen. Zane, what about A versus B? Who's the winner of that pair?
I know
It's a tie. Okay. So one of the things you can do to make this easier on you, I probably should have mentioned this at the beginning, is to be able to identify ties and the winner quicker, is add up, find out how many voters there are. So in this case, there's, let's see, 10 to 16, 18, is that right? There's 18 total voters, which means 9. 9 would be a tie, and if someone has more than 9, then they're going to be the winner. So this way, what you could do is to figure out if you have a tie or if one person is going to be the winner quicker, you could just start working your way across and adding up the number that would have, like with this A versus B, the number that would favor A, let's say. So I would be like, okay, those people favor A. And then if I get to the end, well, if I ever get to a point where I have more than 9, then I'm done. And if I have less than 9, then I don't have to add up the B's, because I know that B is a winner. So in this case, I have exactly 9, so just as Zane said, this is a tie. So I'll just put down a tie here, so tie. All right, so let me see, get rid of my highlights. There you go. Get rid of highlighting, there it goes. Okay, so let's go on to the next one, A versus C. So target is 9, and if you have fewer than 9, you're a loser, and if you have more than 9, you're a winner. So what about you, Jaron? What about A versus C? Also a tie? My goodness. Well, it's okay. We're going to be okay. We'll deal with the ties. Julia, what about A versus D? Okay, surely not another tie. So A is going to win this. Very good. Okay, so now we'll go on to the B's, the B versus C. So, oh, we looped around. I should have just picked. Evan, what about you? What's B versus C?
B versus C.
C is the winner? All right. And if anyone disagrees, we can always go through and count. Like I said, just add up one of the people, and you've got, what your target is. Reagan, what about B versus D? Another tie? My goodness, who made this up? I think I did. Okay, one more. Sydney, the final one, C versus D. Is it D? Let's double check. So, because if it's on the edge. So what we're going to do is we got to figure out who's the winner. So these people prefer C. So C versus D. These people prefer C. These people prefer C. Those people prefer D, 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 and D. So you're just counting up, and it looks like 8 for C, so you're right. It is D. So D is the winner. Oh, no. No. Come back. Oh, why did it mark like that? Just a minute. Here. Come on. It's not going away. Why is this? Sorry. I don't know why it's doing this. Where's my... There it is. Phew. I don't know why it just did that. Maybe I don't know. Doesn't matter. We're back. Okay, so this is D. Very nice. So let's total this up. So we have A has 1 win. So it looks to me, so I'm curious, like I know how I would interpret this, but I'm curious how, especially the Condorcet people, the people that presented this, because I remember there was some question about the ties. How would we deal with this situation? Like who should be the winner? A has 1 win, C has 1 win, and D has 1 win. We've got a bunch of ties. So what was the ruling? I don't have my book with me now. What was the in our book? What did they do? Who were the Condorcet people? Were you guys the Condorcet? So what would you say we should do here with all these ties? Just out of curiosity, yeah.
Usually count ties as like half.
Oh, so is that
and a loss.
okay? So 1 win and 1 loss or something. So Yeah, so I guess the record, if we're going with records, Team A has 1 win, 2 ties, no losses. Okay, so then that resolves it because, wait, does it? Because Team C, Team D, okay, no, Team D has 1 loss. Team C has 1 win, 1 loss. Okay, Team C has a loss. Team B only has ties and a loss. Okay, yeah, so Team A is the winner, right? If we're, so, yeah, I guess if it's like a sporting metaphor, isn't that sort of what, it feels like a sporting, like you're doing a round robin tournament here, where every team plays every other team. So, okay, A is the winner. I'm happy with that now. Okay, so here's the situation, is that once, just before the election happens, whoops, a very sad thing happens, and there it is, person D. Person D passes away. Once again, it was not an assassination, it was just natural causes. He was 99 and just died in his sleep. It was a beautiful situation. But anyway, getting back, so there's person D is gone. So just to back up, person D was not the winner. Person A was the winner, candidate A was the winner. And so candidate D, if they passed away, should that even affect anything? Well, let's find out. I think you know the answer, is that it will. But what I've done here is I've just taken this to make things a little easier on us. Because this happened just before the election, let's just get rid of that candidate and say, here's the new preference schedule. So I've kind of taken this and gotten rid of the little skull and crossbones, and all we have here are the A's, B's, and C's. So now, because there's only 3 candidates, there are only going to be 3 different comparisons. So there they are. So do your comparisons there, and take a minute and work those through. Okay, so we have the same target. I don't know if you can do this quickly or not. We're going to find out, aren't we? So maybe I'll just go around and try to hit the people I haven't bugged yet. Roston, what about A versus B? Who's the winner of that? It's a tie again. Okay, so yeah, if you have a, well, we'll find out. Let's see how this works out. All right, so then B versus C. Let's see, who haven't I bugged yet? Maybe Sarah. What do you have for B versus C? What's that? Oh, you're writing it down. Oh, I'm sorry. Yeah. Well, we could just do it up here. We could just, let's see. So let's go with the B versus C. I guess these people will prefer C. So then these people will prefer C. And then, yeah, I guess because of those people. And then those people. So C gets, is that 11 votes? Yeah, 11, clearly more. So yeah, so C is the winner. Good job. All right, one more, and that's A versus C. Let's see. I don't know. Evan, do you know what A versus C is?
Tie.
It's a tie as well. Okay, so tie. Oh, interesting. So now in this case, we have C is the winner. Isn't that right? Because C has 1 win, 1 tie. A has 2 ties now. You've kind of taken away A's win. And so when you have this sort of a situation, what this indicates is that there is a possibility that back here, the voters could have manipulated, some of the voters could have manipulated their vote. Kind of like it was really obvious with the plurality election. Here it's not so obvious how they could manipulate their vote, but it is possible for some of the electors, the voters, to manipulate their votes to change the outcome of this election from A to C. And I don't know if you can see which voters would be able to do this, but what you're looking for is you're looking for voters who prefer C to A. So like here, it's not these voters. They wouldn't have any incentive to change anything, but these voters might. They might say, hey, I would prefer for C to be the winner. These people would have an incentive because they would prefer for C to be the winner. And I think and these people. So those are the people who you would want to look at and say, could they manipulate their votes? And in particular, if you take a look at these voters right here, if they were to manipulate their vote, that is, change their vote so that C was on top and D was down here, so just swap those two, what that's going to do is that's going to change this in particular. It'll change some other stuff, but it'll change the outcome of this so that C is the winner of that particular head-to-head match. And so then C would be the clear winner with 2 wins and a tie. So that's I guess the thing that that mathematicians back in the 1960s and 1970s sort of figured out, that that anytime you have something like this, one of these criteria is violated, it means that there's a possibility of voters manipulating their votes, sort of getting together and saying, you know, even though we prefer D, we certainly prefer C over A, and if we change some things up in the way that we vote, we can change the outcome of the election. So it turns it into a game rather than into figuring out who is the best candidate. Anyway, the thing that you're going to read for Monday will, or not Monday, I keep forgetting, Tuesday, Thursday. Tuesday is an attempt that this guy, Kenneth Arrow, who studied this and won a Nobel Prize actually for his work on this, he came up with a method that ameliorates many of the issues that, that we're seeing here. But it's kind of a radical change of how we view elections. So, but I'd be curious when you read that to see what you think of it. But anyway, let's see. Let's get back here. So I think that we've got this, whoops, there it is, irrelevant alternatives. Got a pretty good understanding of that. Let's go back and take a look at the others. The other ones, Condorcet method. We already had, I think, something to illustrate that. Monotonicity. That's the one that is the most, the one that might be the most confusing at this point. So irrelevant alternatives usually is the most confusing, but that's pretty, I think we have it in hand, that if you have a loser that drops out of the election, it shouldn't change who the winner is. That's what that criterion says. And it's something that you can't avoid with certain methods. Monotonicity. Oh, wait, let's do these first. Condorcet, just to remind you, if you have someone who can beat every other candidate in a head-to-head match, that is, you have someone who dominates in head-to-head matches, like face-to-face, one-on-one, then they should be the winner of whatever election is, and I think we had some illustrations of that being violated. Majority just says, oh wait, we didn't have an illustration of that, although that one's pretty easy to understand. Here, I'll show you what that looks like. Where is my majority? Do I have majority? Yeah, I think this one is an example. Ooh, that was fascinating. No, that's not an example of majority criterion. Is this one? Yeah, this one. This one's a good example. Okay, and I've done the math for you, so you don't have to worry about it. This is the board account, aka the Zane method, and that is that we're going to give. And here I've got the point values are a little different than the way the book describes it, but it's the equivalent, mathematically equivalent. You're just adding 1 to everybody's vote. That's fine. It's the same exact idea. So here in this election, I did the math. You'll have to trust me on this one. That you have 132 points for A, 164 points for B, 125 points for C, and 89 points for D. I could even put this PowerPoint on Moodle if you're worried. I don't think this is something that you should copy down. The main thing is just to illustrate that B is the winner, and I'm trusting that you understand why, even though you didn't actually do the math yourself, that you trust that I did the math correctly. So B is the winner, but take a look at who would be the winner if you did this with the plurality method. So just take a sec, look at the top row there, and who would be the winner? And I guess I'll go back to randomizing because I don't know how to keep track in my head who has done this already. So Zane, who would be the winner if we just did a plurality? A would be the winner, clearly. A has 26 votes. Now here's the interesting thing about A. Well, let's get back up for a sec. Chelsea, how many voters are there up here? Okay, add those up for a sec, just for a sec. I know it's making you do math on the fly. You can do it. What did you say? 51? Yeah, I think it's 51. So very good. So there's 51 voters. And if you wanted a majority, what would a majority be? So Evan, what's a majority for this? 26. So take a look at this. A not only is the plurality winner, but A, if you think about it, has a majority of people want A to be the winner in this election. And yet A did not win if we use the border count. And the border count is a perfectly good method. It's fine, it's a good method to use, but it fails to satisfy this thing that's called the majority criterion. So that's what the majority criterion says. It just says that if you have a candidate who has a majority of first place votes, then that candidate should be the winner. Now, because of this, once again, this allows board account, you could manipulate the outcome of this particular election. Oh, and I should say, not every election suffers from the majority criterion violation, but it could. This is what mathematicians do, is we come up with these edge cases, we invent these, like, what could go wrong? That's what could go wrong. So if this did happen, there are some voters here who could manipulate their votes to ensure that A was the winner, not only of the majority, but also of the board account. And let's see, who are those people? Give me a sec here. B is the winner. They would be people who prefer A to B, generally. So I think these people, because the rest of these people don't have any incentive to change the outcome from B to A. But how could these people change what, or it's just one person, right? Oh, is that going to be enough though? Okay, you'd have to have these people, I think maybe these people, but in general, let's just see, can anyone see what these 26 people could do to their ballot to change the outcome or to affect the outcome? Is there anything that they could do? Yeah, move B down. Like wait a minute, B's going to win? If I move B to the end, maybe A will win. And you'd have to be careful because moving B down here is going to move C and D up, and so that increases the votes for C and D. Maybe it would be safest, because D is the least favored, to put D second, leave C here, and put B here. So let's see, what would that do? That would reduce B's total by 26 times 2, wouldn't it? So it reduces, that doesn't, because that reduces B's total by 52, and it increases that would put D up too high. I think they'd have to get together and maybe some of them move B to the bottom, D up here, and some of them just move B to the bottom and move both of these up here. This is the sort of thing that you use a spreadsheet for. Like I said, when I made the sheet that I gave you, which had 4 different outcomes for the 4 different methods, I just kept working at it. It's like manipulating things. You move things around, but it can be done. I guarantee it, because this fails the majority criterion. It would be possible. It might take a lot of effort, but it would be possible to change the outcome. So, but that's the sort of thing you would do. Okay, so that's the majority criterion. The last one, monotonicity. Oh, what's that? Oh, what's that? Oh, you had a joke? What?
Yeah, just saying, I have a hole in my sock.
Oh, it has nothing to do with it. I was hoping it was something funny about the election, but that's all right. But anyway, getting back to the last one is the, what is it called? Monotonicity. So monotonicity, where is my monotonicity example? It's right here. Is this it? Just a minute, I need my glasses because these little thumbnails are so small. Yes. Okay, so let's do the runoff method. So it's a good review of the runoff method. So here's, we're going to do the runoff. Ooh, that was fancy. Do the runoff method with this election. So let's take a look at that for just a minute, and we'll do the runoff method. So it shouldn't take too long. Okay, so. And you're going to have 3 rounds, essentially. You know how it works, is you figure out who the winner is, or no, who the loser is, right? You eliminate the, so we're doing the, oh yeah, how did we, you guys, we had 2 different, I think it was the hair elimination method, where we eliminate one at a time is the way I'm going to do it here. So just so you know, because there were 2 different runoff methods that were presented. So it's the one where you eliminate one candidate at a time, the loser, and then the next loser. So I think it's probably obvious. You can see just looking at this who's going to be eliminated first. So I probably can just pick someone. Jaron, you know who gets eliminated first, don't you? Yeah, it's D, and it's because here's the numbers I got is A, B, C, and then D has only 3 votes. So we'll get rid of D. So get rid of D. Let's crumple that up, and so we're crossing out D, and then we go on and we pick the next loser, or find the next loser. So this one's not quite as obvious, but just bear in mind that those 3 people who would have voted for D are now voting for A. I guess this would have been the same had we used the runoff where you just take the top 2 candidates. Isn't that what the other runoff was? The runoff people is you, but anyway, I'm just doing it one step at a time. All right, so Zane, who gets eliminated now? B, what? Is it B? Yeah, I guess it is B. Huh, they have 21 votes. Okay, because A has 22, 21. You're right, B. Very good. So we'll get rid of B. Let's see what happens. Ooh, we turn the page. Oh, I guess I got the answer right there. So the final answer here is that with the runoff method, C is the winner if you use this one at a time runoff. Now here's the thing that's interesting about this is C is the winner, right? C is the winner of this runoff election. But let's suppose that instead of, well, here, let's take a look at this. Yeah, C is the winner. Lovely. Let's go back. There. So going back to the original, just a minute. What is going on? Okay, yeah, going back to the original, it was C that was the winner. Yeah, there, going back. C is the winner. I don't know why I have this slide here, because what I'm really interested in is I'm interested in these 3 people here. Let's suppose that these 3 people change their minds. They previously voted this way, but they're convinced that C is the best candidate, right? So let's say that those 3 people decide instead of voting for D, they're going to vote for C. And so notice here's the only change I'm going to make is you have the winner, C. C is the winner, right? And I'm going to change this arrangement here to look like this. So notice that the only change I made was these 3 people decided to change their votes so that instead of C being in last place, they moved C to first place. That's the only change. That can only help C, can't it? More votes means a better election result, right? That's why you have, well, actually in Ohio we don't have this anymore, but back in the, like 10, 15 years ago, we would get called by all the elections wanted us to vote for them because we mattered. We don't matter anymore because everyone knows who we're voting for, apparently. But anyway, getting back to this. So this is why we care about trying to encourage people to vote for us, right? It's like, hey, we want more people to vote for C. So C was the winner. Now let's just redo the runoff. I won't make you suffer through this. I'll just, because I have it all right here. So in now, the only change is that one column there. Now, here are the votes. So who's going to be eliminated? Obviously D, right? D gets eliminated. Oh, that was fancy. So we get rid of D, and now it's not very exciting because it's basically the same numbers. Now who gets eliminated? It's A. Okay, that's okay. We can eliminate A now. Let's get rid of A. And then check it out. When you get to the final vote, it's B who wins. This is the most paradoxical in my mind of all of these criterion, and that is that you have a group of voters who have changed their mind, decided that they prefer C, who was the winner. And by doing that, they actually caused B to win. Isn't that amazing? I mean, that there, right there, it just seems like completely wrong. So here they are side by side. With this particular preference schedule, C was the winner. With this preference schedule, the only difference being those two things, B is the winner. That just seems so wrong that, I don't know, like this is the one that just blows my mind, is that this could happen. That you could increase your, support and lose the election. So this happens with, well, we'll get to a minute to see this. So this is called monotonicity, or at least it's a violation of monotonicity. Monotonicity says that if one or more voters changes their votes in a way that moves the winner up in their preference schedule, it shouldn't change the outcome. So in other words, if you increase support for C, it should not cause C to lose. So that's the idea there, is that if you increase the support, if you increase, the same thing would be true here, but it would be a little bit more nuanced. Like if this person, these 21 people, if they decided to move C upward then you would think that C would continue to win. Same thing with these people. If they moved C upward, or here, over here, C upward, then C should continue to win. Now, not only is this the one that feels the most paradoxical to me, it also is the one that is the most obvious in terms of voters being able to manipulate the outcome using insincere voting. Because if these three voters know that this is the situation, and if those three voters know that if they change their vote, that it could cause B to be the winner, well, look, B, when they're being honest, B is their preferred candidate to C. They may hate C, but by voting for C, they end up defeating C. So weird. I don't know, I love it when mathematics produces a result like this, in terms of, just something that's almost like magic. But anyway, getting back to our list, here's our list. And you might say, well, we want to have some sort of a perfect, we want to avoid all of these things. So these are the problems. Avoid these problems. And it turns out that all of these election methods on the left, they have problems. Here, I'll just show you. I've got a chart here. In this chart, on it, what I have here, the check mark means that so just to explain what the check mark means. So head-to-head is the Condorcet method, and then runoff, you know what that is. But what the check mark means is that this does not violate. So it's a little confusing the way that, since we've been talking about violating these criteria. So head-to-head method does not violate Condorcet. So the head-to-head method seems to be pretty good. Head-to-head method does not violate the majority criterion. What that means is that if someone has a majority, they will for sure win the election in a head-to-head method. Monotonicity, if you move, like in that last example, if you change the votes so that you improve someone in your bracket or in your the way your preference, it will not change. So those three, those checks just mean that you cannot manipulate head-to-head using Condorcet or majority or monotonicity. None of those, but you can with the irrelevant alternatives. That was the one where if someone dies who is a loser, then someone else wins the election. You'll notice that the runoff method, it only satisfies the majority criterion, and it violates these. Or rather, when you have a blank there, what it means is that I could come up with a preference schedule that would illustrate a violation of Condorcet. I could come up with where you had someone who could beat everyone head to head, but they lose in the runoff. I could come up with one where someone has a majority, but they lose in the runoff. Oh, wait. No. Oh, no, monotonicity, sorry, majority. I was going to say, I misspoke. Majority you can never violate with runoff. Monotonicity, though, I could have a situation where someone increases in fact, we just had one like that. And then board account, you can see it only satisfies monotonicity. That is, if you improve in your preference schedule, you won't change the outcome, but every other criterion is can be violated. Plurality, it only violates Condorcet and irrelevant alternatives, but not the others. So this is the way that, the thing that you're going to read about for Monday, Kenneth Arrow's impossibility theorem and this method that he came up with to avoid all of this, it doesn't refer to these per se, but when you read in that little section about voters manipulating the outcome by insincere voting, that's what it's referring to, is these sorts of things. And you can see that every single method has at least one of these ways that voters could manipulate. So these, I know that they're written as like criteria here, but they're ways that voters could manipulate the outcome of the election. Okay, so what are we doing? We're coming down the home stretch here for today, just a sec. Okay, yeah, we'll get to that. We'll save that. Save that, because that's Tuesday. Okay, so what are you doing? So, these GRE practice problems, they are hard, aren't they? But we're almost to the end of this little booklet, and I think that we won't, there are 66 of these, but I think that the 33 is going to be sufficient. So what I did was, instead of telling you to just do the entire block, I thought to encourage you to actually try them, that what I could do is have you, write them up and hand it in, sort of, like have it, I mean, we can go over but actually write something down on a piece of paper that you're going to give me on Tuesday. So, but here's the thing is, not most of them, but some of these are, topics that you've never had. For example, number 19, you might look at that, and it says, if z is a complex variable, and z bar denotes the complex conjugate of z, what is the limit as z approaches 0 of this function with z bar over z squared? What in the world does that mean? So that sort of thing seems confusing, and you might be able to answer it. There's some things that are from modern algebra, and I know not everyone has had modern algebra here, so we would want to skip over those. But there are some things that I think everyone here should be able to do. Wait, just one more example, just a sec. Where is it? I saw it here. I don't know where it went. There was another one that was kind of cool, but I was pretty sure that not everyone would know how to answer it. Well, if I see it. I was just reading this. Just a minute. Oh, I see it now. Okay, I see it. Okay, so, yeah, I want to add that. That is so cool. Okay, well, anyway, maybe I will. But here's what you're supposed to do for Tuesday. So GRE practice test, I've picked the ones that are like calculus type problems or other math that I think that you can do. So there are going to be some of them harder, some of them easier. There's actually some pre-calculus in here, believe it or not. that you'll happen upon. It's pre-calculus that you probably have forgotten, or maybe you it got glossed over when you took pre-calculus, but there are the problems that I'd like you to try. Write them up so that you can hand them in. And this, I don't know that it's going to be really all that possible to cheat on these. At the very least, you're going to have to do something other than just, like with that one, what is it? Wasn't there one where you're just comparing numbers? Yeah, number 6. Number 6, you just punch it in there. I don't think that any of these you can do that with. So do your best. And then number 2, the second thing to do is pick 2 voting methods. So this is pretty straightforward, pretty quick. You can do this probably just sitting here right now, but it won't take you long. Invent a preference schedule. So do what I've been doing. Invent a preference schedule with more than 2 candidates, so you need 3 or more candidates, but probably 3 would be the way that you'd go. So come up with a preference schedule for which the 2 voting methods you choose result in 2 different winners. So just to get you started on this, the way that I would approach this is I might pick plurality, because plurality is an easy one to pick on, and one of the other methods, you can choose your own, and then I start out by making up my preference schedule. I'm going to do 3, A, B, C, B, A, C. There's going to be 6 of these, C, B, A. But anyway, I might start just with this, and then just decide, okay, A is going to be the plurality winner. So if you do this, and then I might have gotten lucky and had whatever my other method, like board account, maybe A is the, you know what, if I want A to be the loser in board account, it probably would be helpful if I moved A downward. Oops, why is that doing it like that? Just a sec. There, like if I change this. So anyway, do some manipulating, moving it around until you have a situation. It won't take long, trust me, it's not that hard to do. So there's that. Let me get rid of this. And then the third thing is activity 8. I've already mentioned this a couple times. This is Kenneth Arrow's impossibility theorem. That is to say, it is impossible for an election procedure with more than 2 candidates to avoid all of the pitfalls of voting. And so because of that, he came up with another method that's a little different than what we've been doing here. So any voting method like this, got a little erased, where you have a preference schedule, you have number of votes for each candidate, you have people ranking their candidates, that will always fail to meet at least one of the voting fairness criterion. But his method avoids these, but it's a little bit different. You'll see it's not hard. One last thing before you go is on the syllabus, it says we're supposed to have a couple of tests. These are going to be easy. So I thought we could just have one next Thursday. So I'll put that up here on the list. Test 1 next Thursday. It'll be super easy. I'll give you some practice questions like I love to do anyway next Thursday. Yeah, next Thursday. So next Tuesday, I'll give you some practice questions so you know what to expect. But you already know what it's going to be. It's just going to be a bunch of voting methods. So do you know what the board account is? I'll have something simple. Nothing that's going to take forever. So I'll have one of each of the voting methods and maybe some other questions regarding voting. But it'll be a simple test. You'll all get hundreds, I hope. I think you could get 100 even if I gave it to you today. That's how easy I think it's going to be for you. All right, I think that's it. Any concerns or questions? You have 5 days, so hopefully you can handle this. You might want to look at some of those GRE problems today so that you get them in your head. And then we'll go, and the one that I was thinking of is number 19. We could put that as a bonus. Bonus, 19. So 19 is, wait, is it 19? I'm sorry, no, it's not 19. I should have put my glasses on. Just a sec, I'll tell you what the bonus is. Oh, it's 27, sorry, 27. Just because I suspect that some of you might be able to do that just based on your pre-calculus knowledge. Maybe not, but it's kind of a fun one. So go to it, and we'll see you on, I guess, on Tuesday. Some of you I'll see before Tuesday. I'll stop the recording in case anyone wants to come whisper something to me up here.